What's up? It's time for some math. Chapter 5, review. All of it. There's so much of it. Plus, we're like, it's been weeks, right? We had Thanksgiving break. Well, you know what? Actually, if you're going to watch this video in the future and we don't have it around there, then this is going to be weird. But whatever. Right now, in 2021, we just had Thanksgiving break. We're testing. Oh, my goodness. Let's review, okay? And right now, they had some free food in the teacher's lounge. So, got me some ranch Doritos. Best chips, by the way. Cool Ranch Doritos is the best flavor. Could be a trivia question later on. I don't know. Had a couple little Sammys, and I got an M&M cookie. I'm pretty psyched about it. Oh, couldn't see it. There it is. All right, let's do this. So, first one. We've got those two lines that are parallel with the transversal. We know that the measure of angle 3 is 40 degrees. So, let's get a different color pen up here. Oop, not that. There we go. So, this guy right here is 40. The measure of angle 6, that's a same side interior angle to that, so they're supplementary. 180 minus 40 equals 40. Beautiful. Sorry, oh my gosh, 140. All right, so 140 degrees for the measure of angle 6. Done with the first problem. All right, this next one here. Find the restrictions on x, if you can read that handwriting. Sorry, it's a little sloppy. I'm trying to move fast. All right, so we got our triangle here. A lot of you came with questions already on this type of problem, so why not address it here? This is the exterior angle triangle inequality theorem. All right. So I know that that exterior angle has to be bigger than either remote interior angle. So bigger than this one here. That you can't see that highlighter. I thought you were going to be able to see that. That was going to be awesome. It's got to be bigger than this one, and it's got to be bigger than that one, right? I have information about that bottom right one. So I know that 2x plus 10 is going to be greater, it's going to be greater than 50, right? But it can't get too big, okay? Can't get too big. What's my limit of how big that angle can get? 180 degrees. So basically, this exterior angle right here has to be between 180 and 50. Okay? Had those two been flip-flopped, you know what? I'll just do an example like that in a second. Let's solve this one. So subtract 10, I get 40. And over here, I'm going to get 170. So I get 2x is between. And now I'm going to divide by 2. And I can do this all at once. Okay? So then I'm going to divide by 2. I get 20. It's less than x. Then 170 divided by 2 is what, 85? Cool. That reminds me of Elf. How many did he make? 85 for those, the jack. Yep. All right. I knew. Cool. Awesome. Let me drop another one with the other scenario. All right. So let's say we have our exterior angle here is 100. The interior, the remote interior is 4x minus 20 degrees. Well, I know that in this scenario, the 100 is going to be bigger. So my upper bound, if you will, is 100. So that's got to be less than 100. We can't get too small, so it's got to be greater than 0. So sloppy greater than sign. Let me slow down here. All righty, so now I can just solve it the same way I did before. I'm going to add 20 to everything. So now I have 4x in between. Divide by 4, and I'm going to get 5, and I will get 30. There's my final answer. Those are my restrictions on x. Both scenarios there. You do have to pick either it's 0 or 180 that you end up having to use. That is why I picked 180 in the first one, and this is why I picked 0 in the second one. All right, next one here. I want to solve for x and y given this diagram. So I've got two parallel lines. Got a little triangle thing going on there. I got a right angle as well. Let's see what we can come up with. Well, if that's a right angle there, wouldn't that make this a right angle here as well? If they're parallel lines, those two angles should be congruent. Those are corresponding angles. It looks a little jacked up, but they are nonetheless. All right. Now, let's see here. I've got two parallel lines. Those are same side interior angles, meaning this one here and this one here. So they'd add to 180, but then I'm dealing with two variables. I wonder if there's a way we can do this without. I do know in a triangle, all the angles add up to 180. Okay? I've got 90 right here. I've got 20 over here, and then the 2y. That's all part of one big triangle right there, right? So I can have 2y plus 20 plus 90 equals 180. So I'm going to end up with 2y equals 70. So y would equal 35. Okay. And if that's 35, I know that the 2y over here, that's going to be a 70-degree angle now, right? Now we could set up, I'm going to pop up top here because I ran out of room below, 70 plus 4x minus 10 equal to 180. All right, combine some like terms. Let's see here. So I'm going to have 4x plus 60 equals 180. 4x equals 120. So x is equal to 30 degrees, or just, I guess, 30. Just say 30. I like it. Beautiful. I got x, I got y. I use what I know about triangles and also my same side interior angles being supplementary. Awesome sauce. All right. Wonderful crook problem, as we like to call it. So this is find the measure of angle 1. Cool. Awesome. Well, let's see here. We like to. I should probably add some values. One sec. There we go. All right. We're going to add some angles. So I've got a couple angles here. We'll figure it out from there. Well, let's see here. The measure of 40, that's 40 there. So what if I do this? What if I draw half and half? So this right here, that's my 40 over on that diagram, which would correspond to this spot right here. Those are alternate interior angles. This is 40, which makes this guy 40 right there too. I can use the same thought process with the bottom half. This being 110, what does that make this? That makes this guy 70. They are same side interior angles, so they are supplementary. So this guy right here, 70 degrees. Now together, 40 plus 70 gives me 110 degrees. That is a coincidence that it is also the same as the 110 here. All right, if this was 50 up here, then that would be a totally different answer. So just a coincidence that those two are the same measure. That's not always going to happen that way. Awesome. Whoop. All right. Are these lines parallel? That's going to be our question here. So are the two lines parallel? We could label them like A and B or whatever, but let's see if we can figure it out. We also have to justify it. I can't just say, yeah, they look like it, bro. All right. Well, what do I know here? Well, I've got 3 different angles labeled, right? Now, these two here and here, those are alternate interior angles. And if they are congruent, then these are parallel lines. But I don't know if they're parallel. So I can't set those two equal yet. What I do know, though, is that these two are vertical angles. Therefore, they are congruent. So 3x minus 4 is equal to 50. 3x equals 54. So x is equal to 18. Now I can use that to see if my lines are parallel. If I plug 18 in here, obviously this one's going to be 50 degrees again because it's vertical with the other 50-degree angle. Now over here, if I plug that in, 2 times 18 plus 16, I have, let's see here, 36 plus 16, that's 52 degrees. Those are 2 different measures, not parallel. And I would justify this with alternate interior angles not congruent. Okay, we do need to justify why. It will ask you, use a theorem to justify. Cool? Awesome sauce. All righty. A proof. Let's do a proof. I love proofs. They're my favorite. I haven't done a ton of them, but you know they're great when they're there. Okay. We have a parallelogram. We want to prove 2 triangles congruent. ABC and CDA. All right. Let's do it. So if I want to prove 2 triangles congruent, I'm going to need like side, 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 or side, angle, side, or angle, side, angle, whatever. Cool? We got a lot going on here with the 2 diagonals here. But let's see here. In a parallelogram, my opposite sides are congruent. Right? So I've already got 2 pairs of sides to prove these 2 triangles congruent. That's awesome. That makes us very, we're almost there. We got options here for the rest. All right? 2 options. I can either use reflexive property to prove AC is congruent to itself, or, there we go, or I could say the opposite angles of a parallelogram are congruent. Either one's okay. All right. I'm gonna go old school with reflexive property just because. All right. Let's see here. Given first one is AB is congruent to DC, and I also have AD is congruent to BC. That is step 2. All right. And that's if we have a parallelogram, then opposite sides congruent. Step 3. AC is congruent to itself. Reflexive property. And then step 4, where I'm running out of room, sorry. Step 4 will be triangle ABC is congruent to triangle CDA. And my reason would be, I got 4 sides, don't I? Side, side, side. If you were to have done angle ABC and angle ADC congruent by if a parallelogram, then opposite angles congruent, you'd be doing SAS, S-A-S. Lovely. All right. So here what we're going to do is going to give the most specific name for the quadrilateral. Sorry I didn't write it down. My handwriting gets sloppy. I'm trying to move quick here because I have like 10 minutes to get this rest of this video done so we can upload. All right, let's go. So the first one here, let's see here. I have all sides congruent. If all the sides are congruent, that narrows it down to a rhombus or a square. Okay? I have perpendicular diagonals. That's either a rhombus or a square. Can I get to a square here? There's nothing more specific here, so I have to just go with rhombus because there's nothing else to tell me that I can get more specific. If I had something like, there we go, 2 of them. If I had that going on, then yes, I could say it's a square. Or if I had, one sec, there we go. If I had a right angle here, which would then give me all right angles based on properties, then I could have a square. But because I have nothing additional, all I have is a rhombus here. Cool? Next one. Here I've got, once again, perpendicular diagonals. This time, I've got one pair is bisected as well. So one diagonal perpendicularly bisects the other. That is a property of a kite. We can't say that it's a rhombus because the other two, these would also have to be congruent as well to be a rhombus. So in this case, we're going to say it's a kite. Cool? Awesome. Always, sometimes, never time. A square is a rectangle. Does it have 4 right angles? That's all you need to be a rectangle. It does. It will always be a rectangle. A rhombus is a square. It has all congruent sides, but do we have 4 right angles? Not necessarily in a rhombus. So this is a sometimes situation. Parallelogram is a rectangle. Well, the opposite sides are parallel, and the opposite sides are congruent. Same with a rectangle. But do we have 4 right angles? No. So this is a sometimes. I didn't mean to do that. All right. Anywho, if you are moving down the family tree, okay. So if I'm moving down the family tree, then we are doing a sometimes. Okay? A parallelogram is sometimes a rhombus, sometimes a rectangle, sometimes a square. If we're going up, and we're talking specifically about like our parallelogram area there. If we're going up that family tree, always. Okay? Even if we're going like up with like a kite is a quadrilateral, yeah, always is. A trapezoid is a quadrilateral, yeah, 4 sides. All right, cool. Let's continue. All right, we got ourselves another hefty problem here, if you will. All right. ABCD is an isosceles trapezoid. Congruent. Parallel. I'm marking it, brother. I'm marking it. All right. BC is 12. Measure of angle A is 2x plus 6. Measure of angle C is 8x plus 4. And then I have AD is 5x minus 1, my goodness. And CD is 3x. Woo! All right. What do we got? What are we going to do? Okay. I got an idea. First off, one upper baseline angle and one lower base angle, they are going to be supplementary. So 2x plus 6 plus 8x plus 4, that equals 180. I know this thing is like, whoop, but that's an upper base and a lower base angle, so we compare them. So I have 10x plus 10 equals 180. So 10x equals 170. So x equals 17. Lovely. Fantastic. Wonderful. All right. It wants you to find the perimeter. Well, I've already got one side here, 12, right? I need to plug in for the rest. Well, 5 times 17, I'm not going to do things in my head because then I make mistakes, and it's recorded forever in a video. If I plug 17 in over here, I get 84. All right, so 5 times 17 minus 1 equals 84. Awesome. 3 times 17, it's going to be 51. Yeah, cool. And then if that's 51, this is also 51 over here. And if I add all these together, 84 plus 51 plus 51 plus 12, 198. There's my perimeter. Woo! Awesome. All right. Ooh, wonderful. Kite problem. So ABCD is a kite, and we also have the congruent segments marked so we can kind of know what orientation we're dealing with here. The measure of angle 1 is x squared plus 13x. Ooh, what do we know about the diagonals? In the diagonals of a kite, they are perpendicular, and one of them bisects the other. And because of the other markings here, and I should use 3 here, those are my 2 congruent segments. Take a look at your kite diagram if you're like, wait, what? Okay. I know the measure of angle 1, I guess I could have marked that here, is a right angle. It's a 90-degree angle. So x squared plus 13x equals 90. And if I'm going to solve this, I got to set it equal to 0 because it's a quadratic. So x squared plus 13x minus 90 equals 0. So when I factor this, I'm going to have x plus 18 and x minus 5. 18 and 5 multiplied to negative 90. 18 and negative 5 add to 13. So I'm going to get x equals negative 18 and x equals 5. Now, positive and negative values, those are all fine and dandy until I plug them back in. I got to make sure that I don't get negative lengths or negative angle measures. Well, because it's right here, BCA is 2x, I got to nix this one here because that's going to give me negative 36, right? Measure of angle BCA equals 2 times negative 18, negative 36. Sorry, it's getting really small there. There we go. Equals negative 36. That's not okay. All right. But the measure of angle BCA equaling 2 times 5, which equals 10, that's Gucci. So BCA is this one here, so 10. But it asks for this entire angle here. Well, we do know that one of those diagonals is going to bisect the angles there, the opposite angles, and this is the one. We got this like line of symmetry down here for the one that's perpendicularly bisecting. It's cutting that whole kite in half. So my final answer here is 20 degrees. Whew. Love it. All right, wonderful. All right, here we're going to give the most specific name to the quadrilateral that we could possibly give here. All right, so got a bit of work to do here, and I'm running low on time, so we're going to have to go super fast. All right, so first off, my slopes. I'm going to start with my slopes, all right? The slope of this horizontal line is equal to 0. This slope here, I go up 8, and I go over 3, so 8/3, positive 8/3. Here I have another slope of 0, horizontal line. How wonderful. And here I have a slope of, again, 8/3. Okay, so what does this tell us, right? You guys are all pretty good at calculating your slopes, but what does it tell us? All right, so opposite sides parallel. Yes or no? Yes. Okay. How about my consecutive sides perpendicular? No. Okay, so what does this narrow it down to, right? If my slopes were opposite reciprocals, then that answer would be yes. But they are not opposite reciprocals. 0 and 8/3 are not opposite reciprocals. So the answer is no, that they are not perpendicular. Okay, so parallel, opposite sides parallel, and not having right angles. We are in the parallelogram or rhombus. It's one of these two, okay? Kite's out, trapezoid's out, isosceles trapezoid's out, all right, although square and rectangle are out, no right angles, right? So it's one of those two. How do I get the, figure that out between those two? Well, I'm going to take a look at my diagonals, okay? Both my diagonals. If those are perpendicular, they're looking pretty close. Then it'd be a rhombus. If they are not perpendicular, then it's not a rhombus. So let's count it out. I would go down 8, and I'd go over, let's see here, 4, and then 2, is it? Yeah. So I'm going down 8 and over, what did I say again? 6. So it's negative 4/3. Okay. My other diagonal, I'm going up from 3 up to 5, so it's up 8. And I'm going over from negative 7 all the way over to 4. It's over 11. So that's 8 over 11. Right? Rise over run. There we go. That does not simplify. So these are my two slopes. Are they perpendicular? No. So parallelogram is my answer for this one. I hope I counted those out correctly. All right, we got 3 minutes to the bell, so I got to pause or stop this thing so that it can load to the interwebs and the cloud and things like that. Not everything was covered, but a good amount of stuff. I hope this helps. Have a wonderful day. America, freedom, rock and roll, Costco. Yo, Ro. Riverdog Jenny on the gram. And America, did I say that yet? I don't know. See ya.